Hey there, this is going to be a short video lesson over Module 1A, Factoring Special Products. So I don't have a PowerPoint made up, so I'm just going to be writing the problems down for us to practice together. And you'll find the same problems in your exercises for Module 1A, Factoring Special Products. So before we do that, in order to be able to factor these, you need to remember, or rather, it's a good idea to just review multiplication so that you can see, let me just go to the next slide, what it looks like if you multiply, for instance, something that looks like to start with. So let's multiply 2x minus 3 times 2x plus 3. So this is going to give us our first special product. Okay, so I want to review multiplication before we do the factoring because it'll help you understand the factoring more. I guess that's what I wanted to say before I just kind of stopped with my words. Now notice these two binomials, they only differ by their sign. They're called conjugate binomials. If you want me to write that down, I can. I'm not going to test you on it. Okay, so remember, when we multiply these together, we can just use our acronym FOIL, first, outer, inner, last, to do this. Remember, when we're multiplying, we add our exponents together, and I will just change my ink color for variety. So we know that first times first, 2x times 2x is 4x squared. We do our outer, 2x times 3 is positive 6x. My inner, negative 3 times 2x is negative 6x. And then the last of this binomial times the last of this produces a negative 9. Now notice when I combine my outer and inner, because those are like terms, we have positive 6x and negative 6x. And notice that those add up to 0. So I'm left with 4x squared minus 9. This, as you may recall, is called a difference of squares. So this is one of our special products. And there's two of them we're going to be talking about. So one of our special products is called a difference of squares. So this is one of the guys that we're going to be factoring in this section. So let me just start with a couple examples. Well, I'll just go back to this. So let's just say we started with 4x squared minus 9. If you started with 4x squared minus 9, and I told you to factor that, you would say, oh, this is a difference of squares. You notice the subtraction sign. That's why it's called a difference. And then you notice the two squares. And remember, a square is just a perfect square is produced when you multiply something times itself. So 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 81 is a perfect square. 10 times 10 is 100. 100 is a perfect square. So to factor this, you would draw your two sets of parentheses. You know that 2x times 2x is 4x squared. You know that 3 times 3 is 9. And then you know that one of these has to be positive and one negative. Or you could write it as 2x minus 3 multiplied by 2x plus 3. Okay, one or the other. And the commutative property of multiplication allows us to do that. So let's just practice multiplying or factoring a few difference of squares. So let's say, and I'll just call this number 1. I tell you, and all of these we're factoring. I tell you to factor z squared minus 121. Here's another one, 25x to the second minus 49. So you recognize that both of these are examples of differences of squares. So you'll draw your two sets of parentheses. And by the time I choose my new ink color, you may already have those finished. Draw your two sets of parentheses. You know that z times z is z squared. 11 times 11 is 121. One has to be positive, one has to be negative. Just remember, you could write it as z minus 11 multiplied by z plus 11. That would be correct as well. What do you get when you factor the one next door to that? Draw your two sets of parentheses. What's the square root of 25x squared? Are you saying to yourself 5x? 5x multiplied by 5x is 25x squared. The square root of 49 is 7. We know that one is negative and one is positive. Or, and I'm not going to always write them both ways, but I do want to just drive home that you don't have to put the negative first. 5x plus 7 times 5x minus 7, because of the commutative property of multiplication, is staying the same thing. Now, sometimes you may have something like this. This is like number 4 in your homework. So I will just write it. I may be jumping around on problem numbers. Number 4 in your homework has something like 36 minus x squared. And just recognize that's not in descending order. Don't spend the time to put that in descending order. Draw your two sets of parentheses and factor it. Think of kind of like this is your f, your first, your last. You have no outer and inner because they canceled. The square root of 36 is 6. The square root of x squared is x. One was positive, one was negative. Okay? Now, I do want to point out one thing. Let me say, look at the difference between this. One of those is a difference of squares. One of those is a sum of squares. And hopefully you're saying to yourself, you recognize that the one on the left-hand side is a difference of squares. That's the one that, like we've been factoring in this section. I draw my two sets of parentheses. You recognize that a times a is a squared. 10 times 10 is 100. And because it's a difference of squares, one will be plus, one will be minus. Because if you check your inner is 10a. Your outer gives you negative 10a, and those cancel. That's why you don't have a middle term. Now this one over here is a sum of squares. This binomial is prime. You cannot factor it. Kind of like the number 7 is prime. The only factors of 7 are 1 and 7. 1 and the number itself. Okay? This guy cannot be factored. Let's try this one. 49t to the 4th minus 100. It's a difference of squares. Draw your two sets of parentheses. Ask yourself, what do you multiply by itself to get 49t to the 4th? Well, 7 times 7 is 49, and t squared times t squared is t to the 4th. So I'm going to say 7t squared, 7t squared, and I know that 10 times 10 is 100, 1 positive, 1 negative. All right, so that's what the special product, the difference of squares, looks like. Now let's talk about the other special product. So in other words, to introduce that to you, although for some of you I know it may be a review, let's start with multiplication. Okay, so I believe the first problem I gave you was 2x minus 3 times 2x plus 3. Well, what if I told you to multiply 2x plus 3 raised to the second? Well, that's a binomial that's being squared. In other words, it's a binomial being multiplied by itself. So you would have to expand that first. You would rewrite that as 2x plus 3 multiplied by 2x plus 3. Notice the signs are the same, and then you would FOIL it. 2x times 2x, so I'll put my acronym up there for those of you it helps, FOIL. So 2x times 2x is 4x squared. My outer 2x times 3 is 6x, a positive 6x. My inner gives me another positive 6x. Notice it's different than the difference of squares because those don't cancel out. You get two positive 6x's. And then my last 3 times 3 is 9. My inner and outer do not cancel out. What do you get when you add those two together? 6x plus 6x. Hopefully you're telling yourself 12x. Drop down your positive 9, drop down your 4x squared. So this came from your F, this came from your L. Your outer and inner combined gave you 12x. So these are what we're going to be factoring next. This is a special product also. This is called a perfect square. And it's a perfect square because anytime you multiply something times itself, you get a perfect square. But notice we're left with a trinomial, so it's a perfect square trinomial. And you can recognize that you have a perfect square trinomial. Notice that this is a perfect square because 2x times 2x is 4x squared. The last is a perfect square because 3 times 3 is 9. And then this has to be divisible by 2. Now you have to be careful when you're factoring these because sometimes they will look like a perfect square trinomial, but they're not always one, so be careful. So if I factor this, and obviously we know what the answer is, but let's just say I started with this. You would say, okay, well, 2x times 2x is 4x squared. Looking at your F, looking at your L, I know that 3 times 3 is 9. My signs have to be the same because that's positive. And you know that your inner and your outer have to add up to 12x. 3 times 2x, my inner is 6x. My outer 2x times 3 gives me another 6x. And it looks like that will add up to positive 12x as long as these are both negative. And then you can rewrite your answer as 2x plus 3 raised to the second. So that's an example of a perfect square trinomial. So that's what your two special products will be. You'll either have a difference of squares or a special product. So let's try some of those now. So let's say I tell you to factor x squared plus 20x plus 100. Notice that's positive, so you'll have the same signs. And when you have any trinomial, say, you'll look at this and this just to see, oh, those are perfect squares. Draw your two sets of parentheses. Your F, x times x is x squared. Look at your L. That's a perfect square. 10 times 10 is 100. Your outer and your inner need to add up to 20x. So check your inner. I do my inner and my outer down below, remember. My inner, 10 times x is 10x. My outer 2, x times 10 is 10x. We know it needs to add up to 20x. Positive 20x. These both have to be positive. So your answer is x plus 10 times x plus 10, which you can rewrite as x plus 10 raised to the second. Let's try a few more of those. Now let's try one that's slightly different. This is number 8. z squared minus 12z plus 36. Let's factor this. Draw your two sets of parentheses. You recognize that's a perfect square. Z times z is z squared. That's a perfect square. 6 times 6 is 36. So, z times z is z squared, my first. My last, 6 times 6 is 36. My inner, 6 times z is 6z. My outer, z times 6 is also 6z. This time, though, it needs to add up to a negative 12z. In order to get that, they both need to be negative instead of both positive. So your answer is z minus 6 times z minus 6, which we will rewrite as z minus 6 raised to the second, or z minus 6 squared. And I know I did some of these a little out of order. Here we have 9y to the second minus 12y plus 4. Let's factor that. So another perfect square trinomial, we hope. Whoops. Let me go back. Sorry about that. Three y times 3y is 9y squared. 2 times 2 is 4. And also recognize that negative 12y is divisible by 2. Your F, your L, your outer, and your inner. Draw your two sets of parentheses. 3y times 3y is 9y squared. Look at your L. 2 times 2 is 4. Now we need to make sure our inner and our outer add up to negative 12y. 2 times 3y, our inner is 6y. 3y times 2 is 6y. It needs to add up to negative 12y. In order for that to occur, these would both need to be negative. So our answer is 3y minus 2 multiplied by 3y minus 2, which we'll rewrite as 3y minus 2 raised to the second. Now there is a problem that gets you thinking, but I'll go over it in your homework that looks something like this. It gives you the expression 36x to the second plus bx plus 121. And it's asking you, give the value of b. Well, you know in this section we're dealing with perfect square trinomials, and it looks like that. And it also says factor the expression as a perfect square. So it wants us to factor it also. So let's just go ahead and see what we would do if we factored this. We would draw our two sets of parentheses. This is our f. What do you multiply by itself to get 36x squared? 6x times 6x is 36x squared. What do you multiply by itself to get 121? 11 times 11 is 121. You can take the square root of 121 on your calculator if you need to find that. All right. Our inner and our outer have to add up to this b. 11 times 6x is 66x. 6x times 11 is 66x. Well, that's adding up to 6 plus 6 is 12. 6 plus 6 is 12, 132. So it looks like B has to be equal to 132. Okay, and notice this is positive, which means these are going to both be positive. So if it's saying factor as a perfect square, we're looking at 6x plus 11 raised to the second. Okay? Now there are a couple problems in here where they actually want you to solve them. Not just factor them, but solve them. So I need to give you a heads up on those. We're going to use what's called the zero product property. And it's very simple. You know that if two things multiply together, if A times B is equal to 0, if A times B equals 0, then what does that tell you about A or B? Well, that must mean that A is equal to 0 or B must be equal to 0. So we're going to use that to solve quadratics by factoring. So we did solve some linear equations. In other words, the x's only had an exponent of 1. But now these equations have an x squared. They're quadratics. So we're going to, there's different ways to solve them. And we'll be using some other ways throughout the semester. The quadratic formula, the square root property. We are going to solve these few in this section by factoring, because that's usually the first way you try. So let's just say I give you this problem here, and this is number 12. I give you 64x to the second minus 81 equals 0, and I tell you to solve this. Okay? And really, I want you to solve it by factoring. Okay? So the first thing you're going to do is you're going to factor it. And you see it's a difference of squares. Okay? So we've just learned how to do that. So they're wanting you to use that in this section. You know that 8x times 8x is 64x squared, and you know that 9 times 9 is 81. This is a difference of squares. So what are the signs going to look like? One will be plus and one will be minus. So we factored it. This is where the zero product property comes in. You have 8x plus 9 times 8x minus 9 equals 0. If two things multiplied together equal 0, one of them has to equal 0. Think of like, pretend like 8x plus 9 is your A and 8x minus 9 is your B. If A times B equals 0, either A has to equal 0 or B has to equal 0. So that means either 8x plus 9 has to equal 0 or 8x minus 9 has to equal 0. So step 2 is to set each factor equal to 0. And hopefully you've done this before. And then the last step is just to solve each of these. And those will be your two solutions. And we started out with an equation that had an x squared. So that means we're going to have two solutions. So solving 8x plus 9 equals 0, I need to get my x alone. I'm going to move the 9 over, minus 9 on both sides. 8x equals negative 9. Divide both sides by 8. So x equals negative 9/8. 8x minus 9 equals 0. I'll add 9 to both sides. So 8x equals 9. Divide both sides by 8. So x equals 9/8. So those are the two values that x can be. Those are the two values that you could plug into this equation and have it equal 0. So x is equal to negative 9/8 and positive 9/8. Let's try one more of those. This is number 14 on your homework. So solve 25 x to the second minus 80x plus 64 equals 0. So first we'll factor. We're going to use those same steps that I wrote down in the previous problem. So this is an f. You can see that's a perfect square trinomial, or this looks like a perfect square trinomial. 5x multiplied by 5x is 25x squared. Look at your L. What multiplied by itself equals 64? That's perfect square also. 8 times 8 is 64. Check your inner and your outer. Your inner, 8 times 5x is 40x. 5x times 8 is 40x. We need it to add up to negative 80x. So ask yourself whether they're both negative or both positive. Negative 40 and negative 40 is negative 80. So 5x minus 80 times 5x minus 80 equals 0. Well, both of those factors are the same, so that must mean you only have one thing to set equal to 0. That must mean that 5x minus 80 equals 0. It doesn't make sense to set both of them equal to 0, because when you solve it, you'll get the same thing. So let's go ahead and solve for x. Add 8 to both sides. 5x equals 8. Divide both sides by 5. So x is equal to 8/5. So you only have one solution in this case because both factors are the same. All right, so hopefully that provides you with enough explanation and provides enough examples for you to be able to successfully complete the exercises on your own. Have a good afternoon.